Hello everyone, welcome back to Edexcel Science channel, and now we are at question 18 from 2026 June IAL Physics Unit 2 paper from Edexcel. When sunlight is incident on the surface of a solar panel, an EMF is produced. At the surface of the at the surface of the Earth, the maximum intensity of solar radiation is 1100 watt per meter square. A solar panel at the surface of the Earth is placed at an angle of 57 degrees to the horizontal as shown. So we have a solar panel over here, which is 57 degrees with the surface of the Earth, and the sunlight is coming literally vertically. Okay. Show that the power output of the solar panel is about 260 watts. And the efficiency of the solar panel is only 20%, and the area is 2.2 meters square. Now, guys, we know that the formula for intensity is power per unit area, and it is given in our formula booklet, so you do not have to memorize it. So from here, I can easily find out my power output, which is intensity times area. But the problem is that even though they are mentioning that the intensity is 1100 watts per meter square, we are not actually getting all this intensity. Even if sunlight has an intensity of 1100, this solar panel is not getting 1100. The reason being is that if sunlight was coming directly on the solar panel like this, or like perpendicular to the solar panel, then they would have got 1100 watt per meter square. So what now will happen is the solar panel will only detect a component of the intensity of sunlight. Now, what I am going to do is I'm going to draw a normal line over here. If this angle is 57 degree, then this angle is also 57 degrees. So what the solar panel is going to get is it is going to get cos 57 degree component of the intensity. Okay. So our intensity is going to be 1100 cos 57 times the area of the solar panel, which is 2.2 meters square. And that is going to give us 1318 watts. However, the solar panel also has an efficiency of 20%. So 80% of this energy is going to the surrounding as heat, I suppose. So useful power is basically 20% of 1318. So you just plug it into your calculator and you will get 263.3 watts. And that is basically the same as this. Okay. Moving on to question number A2. A nuclear power station has an annual energy output of 2.53 times 10 to the power 16 joules. It is suggested that 15 million solar panels would be needed to generate the same amount of electricity as this nuclear power station in 1 year. Okay, so the claim is 15 million solar panels in 1 year. Okay, evaluate the validity of this suggestion. Assume that the solar panels generate 260 watt for 5 hours per day. Okay, so they do not produce 260 watt 24/7, obviously, because the sun, is not always up. And even if it's up, it might be like, covered with clouds or something. So yeah, it only produces for 5 hours. That is very sad. Okay. So to find out the power, we basically have to divide energy over time, right? So the energy that is produced um, by the nuclear power station is 2.53 times 10 to the power 16 joules. Now the time is that it produces 5 hours for 365 days, right? Now I have to multiply a 60 to convert the whole thing into minutes. And then I have to multiply another 60 to convert it to seconds, okay? Because second is the SI unit that we can plug into our equations. So that is going to give you 3.85 times 10 to the power 9 watts. Now, we know from the previous question that one solar panel will produce 260 watt, but the watt that is required is 3.85 times 10 to the power 19. So if one produces this much, how many solar panels will be required to produce this amount? So we can find it out by dividing the values. So total power required is this much, and one solar panel produces 260 watt. So if I divide them, it's going to give me 1.48 times 10 to the power 7. If I do a little bit of adjusting, it will become 14.8 times 10 to the power 6. I just want to convert this into million so that it's easily comparable to the value that they are claiming. So 10 to the power 6 is basically million. So we need 14.8 million solar panels to equal this energy. Okay. But they're saying 15 million. So I guess the suggestion is correct. Okay. So you can say that 14.8 is very close to 15. So the suggestion is correct. Okay. So that is it for question number A. Moving on to question number B. A solar panel is a combination of solar cells. The solar cells can be connected in series or in parallel as shown. Okay. So this is the series combination and the parallel combination. The intensity of light incident on each combination is the same. Explain how both combinations of solar cells produce the same power output and state an advantage for each combination. Okay. So this question is very interesting. Yes, it is true that series and parallel will produce the same power output, but there is, I think, an advantage with parallel circuit, which is that um, 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 let's say that this cell fails and there is no flow of current, then the entire series circuit will fail. Okay, so that solar panel, that unit of solar panel will not work until you fix that particular unit. But the thing with parallel is that even if this one fails, these two will keep on working. So that 5 hours is not going to be wasted on that particular solar panel. But now let's go to how they produce the same power out. Um, Let me explain first and then I'll write the answer, which is that a series circuit has the same current. Okay, they are all going to experience the same current. However, the voltage gets divided. It is the complete opposite in parallel circuit. So in a parallel circuit, the current will get divided among all these solar units or solar cells. However, they're all going to get the same voltage. Okay. So what you see over here is that if current is high and voltage is low, and here current is low and voltage is high. So do you see how the effects of one value increasing is being mitigated by another variable. So even if current is high over here, voltage is decreasing it. Even if voltage is high in parallel circuit, current is going to decrease it, right? So that is why if we follow the formula, power is equals to voltage times current, it's basically the same, right? If your voltage is decreasing, power current is increasing, or if your voltage is increasing, then current is decreasing. So basically, they are balancing each other out. So no matter which circuit you use, you're going to get the same power output. So my first point is going to be that series circuit um, will have same current. Okay. Not only that, um, in series circuit, the voltage gets divided. So let's say this has V1 and V2 and V3. So the total potential difference is basically a sum of all the potential differences. So the total potential difference is the sum of all the potential differences. Okay. On the other hand, in parallel circuit, the potential difference is same. Okay. However, the current is now getting divided. Okay. So total current is the sum of all current in solar cell. Okay. Wait, one second. Yeah, all the stuff. So now the conclusion why they produce the same um, voltage is that power is equals to V times I. So um, actually, I think if you just write this, you will get 1 mark. But let me still explain it. Um, Parallel circuit has higher current while series circuit has higher voltage for each cell. Obviously, yeah. I'm talking. This sentence basically refers to each cell will have higher current in parallel circuit, and each cell will have higher voltage in series circuit. Okay, so the product is always going to be the same. Okay, and one advantage is that parallel circuit will still work um, if one cell fails for some reason. Okay, this question was very interesting. I really enjoyed doing this one. That is it for question number 18, guys. If you have any questions or confusions, you can always comment down below. Please, please, please don't forget to like and subscribe to the channel, and I will see you in the next video.